All right. Beautiful evening, everyone. So this is the exam preparation class we're starting this weekend, and what you expect to see is several questions around several topics you have covered, both O1, O2, and O3. So in this particular class, we'll be doing more of O1. So you'll be getting questions from binary operations, from polynomials, from logarithm, and also from functions. So we'll be starting with function and mapping. So what we want to do now is I'll be giving you about 1 minute or 2 minutes to make an advance into the question. Then I will start solving mine. All right. Now, this is the first question we want to solve. I want you guys to give an attempt on this. Try and start something, read the question, and try and understand what it's trying to tell you to do, and try and find a solution to this question. Of course, I'll be giving you the solution hereafter, but I would love you to, at this point, practice yourself, because obviously this is not the first time we are solving questions on functions and mapping. So what do you feel about this particular question? We have a function, two functions are defined by what we have right here. We have the gx function given as 4 minus 3x. We have the fx function given as x squared plus ax plus b. And both function g and function f, our variable x is defined as an element of real numbers. So we're told that, please always note this information here, we're told that a and b are non-zero constants. That means 0 is not permitted to be any of the values of a and b. So given that, look at the conditions we're given now. Fg, of course, you know what this is called. This is called a composite function. This is f being the parent, g being the child, and x is defined as 2 in this particular expression. And we're told that this composite function was minus 5. And we're told that the other one, where g was the parent, f was the child, was defined as minus 29. So we're told to find the value of a and b. So can you do that very quickly and let me know what your answer is very quickly? I want us to learn to work with time now. Since we all have an understanding of all these topics, let's see how we can work with time. So the fastest finger now, let me see, type your answers very quickly. What's your answer for this question? This is the moment where you want to learn to add speed to whatever solution you're giving. All right. All right, all you have to do is, first of all, attempt to make your composite function where you have f and g. So in trying to do this, obviously, you want to fix in the function g into the function f. So I'm sure we all know how to do that, so we don't have to waste time on this. So if you try fixing function g into function f, that means we'll have 4 minus 3x squared plus a 4 minus 3x plus b. And we're told that our x is 2. So we can go on to have the value of x is 2. So this will be 6, 4 minus 6. That will be minus 2 squared. That will be 4. 4 plus 4 minus 3 times 2, that will be 6. 4 minus, that will be minus 2, that will be minus 2a plus b, and we're told this was equals to minus 5. So obviously we have minus 2a plus b equals to minus 5 minus 4. So we have minus 2a plus b equals to minus 9. So we can try to make this, we can leave it like this, or we can try to make it 2a, that's multiplying through by minus b equals to 9, multiplied through by minus. This is the first equation we'll be having. All right. So you can see how you take it step by step. This is the first equation you'll be having. Don't forget we're told to find a and b. So let's try and do for the other expression we're given. We're told that g being the parent now. So we have g as a parent. That means we have 4 minus 3. Now we're fixing the whole of f inside here. So, and now we have the argument x as 2. So wherever we see x, we can fix in 2. That'll be 2 squared. That'll be 4 plus 2a, because 2 times a is 2a plus b. And we are told all this was minus 29. All right. So this is 4 minus, we have minus 12 minus 2a minus 3b equals to minus 29. So this is minus 8 minus 2a minus 3b equals to minus 29. This is minus 2a minus 3b equals to minus 29 plus 8. And what does minus 29 plus 8 give you? That would be, so you can, okay, so we can bring all this inside here now and have this as the two expression. We can go on to multiply through by minus. So we would have this as our first expression, and we have 2a plus 3b and multiplying through by minus equals to 21. This is our second equation. So we can go on to solve simultaneously, obviously. And if you go through with elimination of a, that you subtract the equation, you will have minus 4b equals to minus 30. So b, obviously, is that correct? Okay. Our b should give us what? I think I've made a mistake somewhere. Okay. I think, oh, sorry. This was supposed to be 6a. This year was supposed to be 6a. 3 times 2 was supposed to be 6a. So where we have 6a. So what we would have done here would have been to divide through by 3. When we divide through by 3, we will be having minus 2a. So this will be minus 2, this will be 2a, and we'll be having just b here. And then we'll be having 7 here. All right, so let's go on to have our simultaneous equation. So if we divide to subtract, we'll be having minus 2b. We divide to subtract, we have minus 2b equals to 2. Of course, that means my b equals to minus 1. And fixing this into any of the equation, I will have 2a minus, I'm fixing into this equation, minus 1 equals to 9. That'll be 2a plus 1 equals to 9. That'll be 2a equals to 8, and our a equals to 4. So therefore, our a was 4, our b was minus 1. How many of you got that correctly? How many of you got that correctly? You got your a to be 4, you got your b to be minus 1. So that's the very first question for the night. Let's move quickly to the next question. I told you we're solving two questions on, okay, I probably did not say that yet, but we're solving two questions on function mapping, and we'll go to binary operation. Now look at this next question, and let me see how you fare with this. We'll be giving just about 2 minutes to solve the question. And please ensure you take a very good note. Okay, so look at these two functions. We have the first function was, and we're told that x is an element of real numbers. Now we have another function g, and we are told that this one was 5x over 2x minus 1. And x was an element of real numbers also. Now, but this has another condition. We're told that x could not be equals to 1 over 2, obviously, because that will make the function undefined. Now, if you can see what we have here, we're now told to evaluate this. I want you to make an attempt to this quickly. You have to find this composite function. And then you have to solve this equation. Okay, so let me see who can get this done very quickly. Look at the function we have here. We have the function 4 minus x squared for the function f. And for the function g, we have 5x over 2x minus 1 for function g. Now, we're told to evaluate, the first question is to evaluate f g minus 1. That means the composite function where the parent was f, the child was g inverse. So we have our x argument as 3. And then we're also to solve this equation. And I hope you understand that when you're told to solve an equation, that means you're supposed to find the value of x or whatever variable you are dealing with. So you're supposed to solve this equation when you have g inverse, the composite function, g inverse being the parent and f being the child, and the composite function was equals to 7 over 5. I'm waiting for great responses. I expect you to have a good idea of solving this. Okay, 1 and 1 over 9, somebody says. Let me get responses from the class. At this point, I'm sure you understand how to solve composite functions. So I want you to put that knowledge to use at this point. What do you get as your answer? Anybody gotten an answer yet? All right, now the very first thing to do, looking at this question, is to, because you are told to find the composite function. Okay, I think I've seen somebody write the answer now. Now, you see, you're supposed to find a composite function between f and g inverse. When you see g inverse, you don't have any expression for g inverse. So you have to go and find g inverse first. So finding g inverse, very simple. That means the inverse of your g function. So you have your g function as this. Your g function was given as 5x over 2x minus 1. This was your g function. Don't forget, the first thing you want to do is to make this y. You make it a linear function. I'm giving you the steps to follow when trying to find the inverse of any function. Now, having this, then the next thing to do is to solve, is to swap for wherever you see x, you fix in y, and wherever you see y, you fix in x. So we have x equals to 5y over 2y minus 1. All right. Then you go on to try and make y the subject of formula. So what do you do in trying to make this the subject of formula? Of course, you want to bring in all of the y's together. So, and the best way to do that is to bring all the equations together. So I want to cross multiply. So I will have 2yx minus x equals to 5y. So I want to bring this, wherever I see y, I want to collect the like times. So I have 2yx minus 5y is equals to x. All right. So I want to make y the subject of formula now. So I have y into 2x minus 5 equals to x. All right. So let me continue that, or let me just clean up the first one. So let me clean up this. I'm sure you guys are flowing with me because this is very pivotal to solving questions on function and mapping. So looking at this, my y will be equals to, obviously, my y will be equals to x over 2x minus 5. So I can then go on to the last step. The last step is for you to now change y. You want to change y to the function. Don't forget we're solving for gx, so this would be g inverse now of x. You change y to that will be x over 2x minus 5. I'm sure you guys can flow with this step. This is something we have explained before. All right. So this is the inverse of the g function. So and we are told to find a composite function between f being the parent and g inverse being the child. So f is the parent now. So f g, let me first do for the normal x, not yet putting the x as 3. Look at this now. To find this, I go on to wherever I see my f because it's the parent. So I have 4 minus, wherever I see x now, I want to fix in the value for the g inverse now. So that will be g inverse is x over 2x minus 5 all square. All right. You can see this. Now, I don't need to waste time. I can go on now to fix in my value of x as 3. So f inverse of 3 will be 4 minus 3 over 2 times 3 minus 5 all square. All right. So we have, this will be 4 minus, this will be 3 over 6 minus 5. That will be 1 all square. So this will be 3 raised to power 2. That will be 9. That will be 4 minus 9. Am I moving the right way? So that will be 4 minus 9. And this will be equals to minus 5. All right. So you can see the answer now to this very first one. We're told to evaluate. The answer is minus 5. I'm sure that makes sense to everyone. This is how easy it is to solve questions like this. And that's why, as I always say, you need to know the basis of every aspect of that topic. Because if you did not know how to truly find the inverse of a function, you will not be able to arrive here. And if you do not understand how to evaluate composite function, you would not be able to do this. Now, the last point was you fixing your x as 3, which when we did, we got the value of -5. All right. Now, if you have understood this, I want you to take your time now to try and solve this next one. And I'm sure you guys are taking good notes. So go on to try and find to solve this expression, G inverse fx equals to 7/5. Make sure you are taking good notes, please. So go on to solve that. All right, I'm seeing answers that are correct. I just saw one. That's nice. That's nice. I love that. So let me see your answers. Let me get responses. How do you solve that expression? All right. So let me start from here. I want to solve this expression. So we have, look at it now, we have G inverse as the parent and the f function is the child. So, I already rubbed our function for G inverse, but of course, I'm sure you guys have it written down. So the function for G inverse, do not forget, we got it as this, x over 2x minus 5. All right. So this is our parent function according to what we have here. The parent is the G inverse. Now the child is the f function. This is the f function right here. So we want to fix this inside wherever we see x. So to now get G inverse with your f as a child, this will be equals to 4, wherever you see x, you put in 4 minus x squared, over 2, wherever you see x, you put 4 minus x squared minus 5. Now, don't forget, we're now told that since G inverse with f as the child is equals to 7/5. So what you want to do now is to equate these two functions, these two expressions together. That's the next step right here. So you want to have 4 minus x squared over you want to have 4 minus x squared over, now let's try and open this if we can. This is 2 times 4. This is 8 minus 2x squared minus 5. So this is equals to 7/5. Step by step, you will not go wrong. Step by step, you can't go wrong. So just follow through and ensure you are following what I'm doing. This is basically the function we have here, the composite function. I just opened my denominator to get this. So 8 minus 5 is obviously going to give you 3. So you can make that smaller. So you have 4 minus x squared over 3 minus 2x squared, because 8 minus 5 is 3, will be equals to 7/5. All right. So what you want to do next is to cross multiply, because that's the easiest thing to do here. So you want to do 5 times what you have here. That will be 5 times 4. That will be 20 minus 5x squared. Then you want to say equals to 7 times 3. That's 21 minus 14x squared. All right. I'm sure you are following what we're doing. So you want to bring in the like terms together. So I want to bring in all the x's on the left hand side. So I have 5x squared, then I have plus 14x squared, then I have the 21 minus 20 on the right hand side. So when I have this, 14 minus 5 will obviously give me 9x squared equals to 1. All right. So we have x squared obviously will be equals to 1 over 9. That's dividing both sides by 9. All right. And according to your mass rule, I'm sure you know that it is okay, very much okay, for you to take the square root of both sides in order to get your solution right here. And if you take the square root of both sides, what you'll be having is your x will be equals to plus or minus 1 over 3. How many people got this answer? You know, you were very sure of yourself, you got this. All right. So it's time to move on to a different topic. So let's try and get into another set of topic now. Let's quickly run into binary operation. So you'll be getting some testy questions on binary operation, and I want you, as we have been doing, to try and solve as soon as possible. But before that, if you are yet to give this video a thumbs up, please do that very quickly. Just show your appreciation and hit the thumbs up button very quickly. All right. Now we have this binary operation question. I want you guys to attempt it very, and I'm sure many of you should be able to get it. But let's see. We're told that a binary operation is defined on a set of positive rational numbers. Pay attention to that. I may not write the whole question in full, just in order to save the time, so that we can solve more questions. So let star, okay, in case you need to have it, let star be a binary operation. I'll write BO, you understand that's binary operation, all right? Defined on the set of positive rational number. And that will be given as Q plus. Now, this is the rule that was defined by the rule. Look at the rule right here, which is the most vital part of your binary operation question. AB over 3. AB follows, of course, as we have said it, element of positive rational numbers. Now, the question is for you to find the inverse of 4 star 6. Let me see how well you do. Find the inverse. Find the inverse of 4 star 6. Find the inverse. Pay attention to the question. We are not told to find 4 star 6, but rather the inverse of 4 star 6. Anybody with an answer already? You have to find the inverse of 4 star 6. No, you people that wrote your answer as 8 is wrong. The answer is not 8. That's why I said pay attention to the question. The question said find the inverse of 4 star 6. No, the answer is not 1 over 8. No, the answer is not 1 over 8. Well, that's the reason why we're here. Let me solve it for you guys. Do we have any other correct answer? No, the answer is not 4. Okay, all right. We have gotten enough responses. Let's do it together, and let's see how we go from there. Now, pay attention. The question said find the inverse of 4 star 6. Now, I'm sure one of the things you guys did was you went on to find what was 4 star 6. So, and I'm sure everybody on this live feed can easily talk about 4 star 6. If you were to find 4 star 6, generally when we are dealing with binary operation, whatever your binary operation is defined on is the most important, which is this. So if I say go on to find 4 star 6, what you wanted to do was to say 4 star 6 is equals to, this is, I always like to tell people that this is first second. So the first second was equals to the first times the second over 3. That was the rule of the binary operation. So when you're trying to find 4 star 6, that means 4 was the first and 6 was the second. That means in this case, this will be 4 times 6 over 3. This is times right here. So this will be 24 over 3, and that will give you 8. All right. So this is 4 star 6, what you would have gotten if you were told to find 4 star 6. But you're not told to find 4 star 6, you are told to find the inverse of 4 star 6. All right. Now we've been able to get 4 star 6 as 8. All right. We need to now go and find the inverse of that 4 star 6. Now, I'm sure you all know this, or in case you don't know, let me tell you that when you have anything in binary operation, any element, when you say, let's say an element A, for instance, just, we can use anything, but let me just use A. This is not symbolic of anything here, it's just A. A binary operation or A star, its inverse, will give you the identity element. Always note this. If you don't know this before, make sure you note this down right now. Very, very important aspect of binary operation. This right here. And what this reads is an element with its inverse is equals to identity element. Now we're told of an element already, which this is the element now. 4 star 6 is actually 8. So 8, that means the meaning of this is that 8 star, let's find any alphabet for calling its inverse. Let's just find anything. Let's put X, let's put Y, anything you want to put. Let me just put X. So anything you want to put here to represent that inverse we're looking for, let's just put it there. Let's say whatever inverse will be, let's put X there. So one thing I'm sure of is that 8, that's the 4 star 6 star, what its inverse must give me the identity element. All right. So we have been able to get the 4 star 6, which was 8. But in order for us to get the inverse, there is something left that we need to find in this expression that we have not gotten, and that's the identity element. So we need to go and find the value of this E. All right. Now this brings us to another important as concept in binary operation, and that is that an element star its identity must give me the element back. This is another thing you should note if you don't know. All these things are things you should note. They are not something that you want to, they are concepts, things that are like set of rules under this topic. That A star, that means an element. This A represents an element. Just know you can put Y there, you can put P there. An element star its identity will give you the element back. I told you already that identity always serves like a mirror. Now, the reason why we are interested in the identity element is because we need it for us to get the inverse based on this particular expression, which is another rule under binary operation. Now, we need to go and find E. So what we need to do right now is to say, what is the element we are dealing with? The element we are dealing with is the element 8. So that means 8 star E should give me 8. All right. So what do we want to go and find? Don't forget your set of rules. This set of rules is the most important part of every question on binary operation, because that means anything you are doing must use this rule. So now that we have gotten 8 star E. We need to go and use our set of rows. That's this one to prosecute this thing here, because this is 8 star E, and we have been told that first star second is equals to first times second over 3. So in this case, when we have the first as 8 and the second as E, that means it will be, we have the first times the second, E in this case, over 3. That will be 8E over 3. But don't forget, that's what 8 star E was equals to. This is what A star E is equals to, 8E over 3. So we'll bring it back here and say 8E over 3 is equals to 8. We want to find E. In this case, you can see that 8E is equals to 24. And E here is equals to 3. All right. So we have gotten now something very important. We have gotten the identity element E to be 3, which is what we were looking for. Now, the next thing we want to do now is to fix that E in this our expression, which was very vital for finding our inverse. All right. So we have 8 star, whatever the inverse was, which we represented as X, is now equals to, we've gotten our E now to be equals to 3. All right. Now, pay attention to this again. Here we are again with another 8 star. Once you see this star, something like this, remember when we saw 8 star E? Remember when we saw 4 star 6? Once you see things like this, you must always refer them back to the original set of rules. You see that when we had 4 star 6, we came back here, we used it to get our answer. When we had 8 star E, we came back here, we used it to get an answer. Now we are having 8 star X. We have to come back here to use it. So what will be 8 star X? We come back to the rule. That will be 8 times, this is first, this is second. First, second over 3. That will be 8 times X over 3 equals to 3. Is it making sense to you guys? So this is the solution for 8 star X. This is it. I came back to use it, the set of rules I was given. All right. Now we have, I can take this off now. I'm sure you have taken these notes. Please ensure your notes are very, very much updated, and ensure you are following and you are solving accordingly. All right. Now, look at what we have now. We have 8x equals to 3 times 3, that's 9. So our x now is equals to 9 over 8. And do not forget, what was our x representing? Our x was representing the inverse of 4 star 6, which was 8. That was what we used to our x to, we made as our x. So that means we have been able to solve the inverse of 4 star 6, which is 9 over 8. Does it make sense to you guys? This is how you solve questions without ever going wrong. So I'm sure you guys followed through on that. I want to go to the next question. If it's fine by you people, I hope I'm not too fast for anybody. All right, so we have successfully solved another question. Let's go now to solve another one yet again. And I will really love you get this answer before I solve it myself. It's quite similar to what we just did. Now look at this. All these questions we are solving are very, very likely questions in your final exam. This is A-level standard where you tend to, this is the kind of question you should expect. So let me see how you do with this. Look at this operation now, this binary operation. We're given mn over 2. And we are told that this follows mn for all mn being an element of positive rational numbers. Now we are to find this. All right, so let me give you about 2 minutes. 2 minutes to solve this. 2 minutes. Let's get this. Let's get this done very quickly. So, what are your answers, or what is your answer? If it's just one answer. I really love the people that are flowing and are giving the responses. Please join up in letting me know how you are faring with these questions. I want you guys to give me your answers. Now that I have solved an example related to this, I would love you to solve this one and show me that you really followed the last one. Let's see how you guys fare in this particular question. Okay. Somebody said the answer is 2/3. Do we have other answers? Someone said the answer is 2/3. Do we have other answers? Two people said the answer was 2/3. Someone else has joined the group. Somebody said 3/2. Some other people said 2/3. All right, let's examine this ourselves. Now we're told that the same thing we did is quite similar to what we're going to be doing. So we know already that if we have an element, you can just pick any, if you have an element m, because we want to find the inverse of this. But don't forget, this is something I just wrote in the last question. An element star its inverse must always give you the identity element. In this case, in binary operation, we represent identity element with E in many cases. So, of course, if you do with a different representation, all you have to do is to make it clear that this is what you are representing your alphabet with. But we have been majorly using E. All right. Now, but for us to find E, we also need to remember that if we take an element with E, we get the element back. So these are the two vital things you need to note. Very, very important you note them at your right hand, or be at your left hand, whichever one. So now, let's go on to try and solve for the identity element first. Or whichever one you want to do. You want to probably do, if you want to go on and first do 4*3, you can go on to do 4*3. 4*3 will give you 4*3. Of course, I told you always make use of your set of rows, which in this case was mn/2, is the most vital part of the whole question. It's the one that will give you all your answers. So this is 4 times 3/2. That will be 12/2. That will be 6. All right. Now, let's try and find our identity element, right? Our identity element, that will be 6*E should give me 6. So what is 6*E? I will go back to my original equation. That will be 6 times E/2. That's 6*E. That will be equals to 6. So that means 6E will be equals to 12. E will be equals to 2. I'm sure we accept this. All right. Now, if we have 6 star its inverse, let's call it x, that should be equals to the identity element 2. I'm using this expression here because this is our operation of interest, 4*3, which we got as 6. So 6 its inverse, which is the inverse we are told to find, is equals to the identity element. So we go back to use the original rule to do 6 star x. That will be 6 times x. Now, let me quickly note that it's not every time you will have your rule like this. It could be anything. Be ready for solving anything. Over 2 equals to 2. That means 6x here is equals to 4. And our x here is equals to 4 over 6, which is 2 over 3. And this x represented my inverse. So the inverse for this question is 2 over 3. So our inverse is 2 over 3. So let's solve for one more question on that binary operation. Let me see how you do this one also. And then we'll move to a different question and see how. I hope you guys are flowing, and I'm sure this is making much better sense, because it's very, very vital that you are very sound in every topic. Imagine this kind of question was what came out on that binary operation alone. You have to be very much ready to solve broadly, applying all the basics under the topic. So all I have done in this on all these questions was apply the basics. Nothing new, no new concept being taught, just application of the basics. So let's see how this you do with this one. I expect you to be faster now, because look at this question. So I may not read out, I may not write all the question because of time, but given that the set Z of integers form a group under the binary operation star. So our binary operation is defined. Binary operation is, I hope you know, it's not every time we define our binary operation as star. So don't get too rigid with the word star. Some people would say you're defining a binary operation with this. So it's not compulsory, it has to be star. So, but of course, it's more one of the most common one being used. So our binary operation is defined as star, and it was defined by A star B being equals to A plus B plus 1. And A and B are elements of integers. So the question then said the inverse of -2 in the group is the inverse of -2 in the group is what? So I think we can use like two minutes to solve that. 2 minutes. So given that the set of integers form a group under the binary operation star, defined by what we have here, A star B being equals to this, and our A and B are all elements of course, this is integers, set of integers. So we're told to evaluate the inverse of -2 in the group. Can I get an answer in like 60 seconds? All right, because of time, I will keep solving while I'm expecting you to shoot your answers to me. Somebody got -4. Okay, somebody got 4. Somebody got -4. People are getting -4. Okay, so all right, let's go on to try and solve. Let's go on and try and solve this. A star E, you know that already, is A. So you know that we are very much interested in the identity element. So identity element, let's try and find it. So of course, this is first and second. Whenever you see things like this, always refer back to the rule of the binary operation. So that means I will have A star E being equals to A plus E plus 1, and that should be equals to A. Of course, now I know that uh, a plus e plus 1 equals to a. That means my e plus 1 is equals to a minus a. I take a to this other side, a minus a. That means my e plus 1 equals to 0. That means my e equals to minus 1. Right? So e equals to minus 1. Right? Now, I'm told to find the inverse of minus 2. The inverse of minus 2. Inverse of minus 2. That means I'm interested in saying minus 2 star its inverse, let's call it x again, should be equals to, based on, of course, this relationship. Don't forget this relationship. Any element star its inverse should be equals to identity element. That's the second rule. So I've used this, I'm using this now. So minus 2 star x should be equals to the identity element minus 1. So we have to revert back to the set of rules again. That means the original rule. Minus 2 star x, which this x here is for the inverse. Don't forget, that's the inverse function, inverse of minus 2. We are represented as x. So this will be minus 2 star x will be minus 2 plus x plus 1. I'm using this back. This is first, this is second. So I'm using this back. Minus 2 star x is this. If you place this back into that original row, so this is equals to minus 1. So minus 2 plus x is equals to minus 1 minus 1. So minus 2 plus x is equals to minus 2. So x is equals to minus 2 plus 2. Our x is equals to 0. All right. So I'm sure you guys could flow with what I just did. So this is how you solve questions. Just follow the set of rules. You cannot go wrong. The most important thing is to know those basics. When you understand the basics, you can't go wrong. But once you don't know the basics, a very simple question will look very technical. So I really hope that maybe, who knows, maybe in some subsequent classes, we will still probably bring in some questions on binary operation. But for tonight, we'll be leaving to, let's quickly touch some questions on logarithm very quickly. And let me see how to remind you of your, to remind your knowledge on logarithm. Let's see if you are still very much apt when it comes to logarithm equations. So this was just like a revision for binary operation. And we'll be touching several other topics. Kuni sections, we'll be touching lots of topics. This is preparation for examination. So let's see this question. Let me see how you do this question on logarithm. So I want you to solve, of course, I want you to always understand that when you are told to solve an equation, just whatever the unknown letters, probably x, probably t, in this case now it's t. So when you hear the word solve, just make sure you try and find that unknown. If it's more than one, find both unknowns. So solving means you should go on to find the unknowns. All right, look at the question right here. You are told to solve this. So please, can you take about 2 minutes to do this and pour your equations, pour your answers back? Can you take like 2 minutes to solve that? If you guys stay consistent, these classes will really boost you academically, I can assure you. I have lots of questions on several topics that I'll be willing to solve. So let me see what you do right here. This is, of course, this is not, these classes, these 9 o'clock classes are not for explaining concepts. They are just to apply all the knowledge you have already. So I'm seeing different answers already. Somebody said 1/3. Somebody said -7/2. Somebody said something else. So can we solve together and let's see what happens here? So I'm sure you understand. Again, the concept of logarithm is vital. Understand the basics of logarithm. So if you don't know the basics of logarithm, this is going to probably look a bit difficult. But once you understand the basics of logarithm, you will know exactly what to do. So look at what I want to do here. This is log 5, this is log 5, and this is log 9. This doesn't even have any log. But I remember something in logarithm, and that thing said that if I have log a, they said this thing is equals to 1. That's something I'm sure many of you probably know. It's a basic concept under logarithm. So when I have something like this, I have log 5 here, I have log 5 here. I want to try and adapt everything having log 5. So I can introduce log 5 to that place, just like to try to conform it in such a way that it has log 5 also. But I would not be just adding anything. I'm going to do something. What I want to do now is it's still going to mean the same thing, just a different form. So I want to just change the form so that I'll be able to apply other concepts. So I'm going to have now, I'm going to write 2, and I'm going to have log 5, 5. So if you say I've cheated, I will say I've not cheated, because log 5, 5 is 1. So if this is 1, this is still 2 times 1, this is still 2. So what I've done here is not anything strange. I've just applied a basic concept in logarithm. Now, I also know something under logarithm, that when I have minus separating two log values, of course, they must have the same base. That's like a condition. Now, if these two things happens and I have minus in between, I'm sure you know what I'm supposed to do there. I can have like a division. So I'm okay with having it like this. I'm not cheated if I do something like this. So that's just it. So now, okay, let me first, I don't know, do you want me to, let me try and do them on the same line because of time and space. So I'm sure you agree with me. Let me just try and explain what I want to do here. That if I have something like this, I'm sure you people agree that I can have it as this. Like this 2 log 5, 5 is the same as this. That's a part of logarithm where I'm permitted to take this as the power. It's just, all these are concepts in logarithm that you have to know. It's part of the basics that I talk about. So now, if you agree with this, that means I can go on now. I can go on now to have, rather than having it like this, I can have it as this. Log 5, then 5 square. All right. So I'm permitted to write that. So, and I can have it like this now. Let me just summarize that. So I have 25. So I'm sure you agree with that. So now, another concept under logarithm that you can apply now is that when you have log 5, when you have the same log, I'm permitted, very much permitted, to cancel the logs out. I'm permitted to do that. All this again is basic concept under logarithm. Once you understand those basic concepts, you can easily apply them to questions. And that's why I always stress the importance of knowing your concept, your basic concept. And that's why I started taking you complex number, so that when we start solving questions on that aspect, I can easily relate back to the basics, which I believe you would have understood. So we are also going to do some classes on calculus, on conic sections. I'm still going to explain conic sections in the virtual class, so that and I'm going to be to try to go as much as I can. Even I will assume you guys don't know it, so whoever has not learned it can learn it from scratch. So looking at what we have here, I can go on to have 40 plus 7 equals to 25t. I'm sure nobody says I've done anything wrong because this is basically cross multiplication that I just did. So I want to collect like terms. So I want to move the t's to one side, and I want to have the one without t in the other side. So this is what I'm going to get at the end, which will give me 1 over 3. So that's just it. It's just basic. Very simple. These are, you can't go wrong when you know the basics. So the secret to guys that gets that excels in all these things is not their brain actually. It's just the fact that they understood the basics. So when you have questions like this, you just apply the basics and you move on. So what I would advise is in your free time, in your leisure time, try and understand the basics of all these concepts, and you will not go wrong. So this is going to be the last question I'll be solving for the night. Try and solve this quickly and give me my answer. It's on logarithm also. So it's similar to what we did. So look at what we have here. I want you to give, you're supposed to solve this. So as I said already, whenever you hear the word solve in any question, you want to find the unknown. So in this case now, you want to find the values for y. So you have log a, you have log y base a, you have log 5y minus 24 base a, and you have log 4 base a. So you want to solve this as soon as possible. I want you to also understand that while preparing for an exam, you also want to work with time. So against tomorrow, tomorrow's classes will cover questions on polynomials. We should cover questions on conics. You don't want to miss tomorrow's slide, I can assure you. Very, very vital aspects that you would see in your examination coming up will be discussed. So you don't even want to miss tomorrow's class, I can assure you. And if you want to be able to solve many of the questions I'll be giving, please try and do some revisions around those topics. Do some revisions around polynomials, do some revisions around conic sections, possibly complex number. We'll be meeting for complex number by 6. So I'll be giving more knowledge on that. And possible we enter some other topics. So just do some brief revision on your on most of your topics, but prioritize polynomials and conic sections. All right, so we'll have an answer here. Okay. Okay. I can see 2 answers. Okay. Okay. All right. Okay, let's solve briefly because of time. Someone got 8 or 12, 12 or 8, 8 or 12, someone 20 or 8, someone 8 or 12. All right, let's investigate and see what happens. So this should not be an issue for anybody because this is quite simple. We have, look at the situation we have here. Look at this, look at this, look at this. Now, this is, all of them are all having the base A. So this is more like a more direct question because you don't have to do anything to change the base or whatever. But one thing is happening here. You can see this 2 here. We can fix this 2 on the top of y. So instead of us having 2 log y, we can have it as log a y square. All right. And log a, then we have 5y minus 24 equals to log a4. So now with what I can see here, this is minus here, so we can obviously make our division here. So this will be log a. We have y squared over 5y minus 24 being equals to log a4. This is quite direct. So that same concept under logarithm that I talked about, where if you have this or this, if you have these two things, they are equal to each other, you can easily, according to the concept under logarithm, cancel this out. So you'll be left with y squared over 5y minus 24 equals to 4. All right. So this is obviously a quadratic expression. You have y squared is equals to 4 times 5y minus 24. So you have y squared equals to 20y minus, what is 24 times 4? That'll be 96. So we have our quadratic expression as y squared minus 20y plus 96 equals to 0. So you can use any method you want to use, but I believe factorization will work very much here. And if you use your factorization method, you will have, I believe you have y squared minus 8y and minus 12y plus 96 equals to 0, because 8 times 12 will give you 96. Minus 8 times minus 12 will give you 96, and minus 8 plus minus 12 will give you minus 20. So you go on to factorize this, you have y into y minus 8, and then you have minus 12 into y minus 8 equals to 0. So you have y minus 8 and you have y minus 12 is equals to 0. My y is equals to 8 or 12. Does this make sense? So guys, this is basically where we're going to stop for today. And I'm sure you can see this is, you've made real progress. If those of you present that has been following, you've made real progress in your understanding of the topics we have covered, and tomorrow is another great day to continue. We are going to be continuing this up until as long as possible, because we just need to get this result. We just need to achieve the result. So guys, please make your revisions on those topics I mentioned, and by 6 p.m. we want to, it's a very important class for everyone. We want to quickly see if we can exhaust conic section, and then by 9 again we'll be meeting for our question class, where we'll be solving lots and lots of questions. There's so many questions. I have more questions that I did not solve for this night. We'll do as much as time can afford us. So guys, please take your time to study very hard. Ensure you do whatever it takes to make A in this year. You have to make A. Make sure that you have all this in your notes. Make sure you're ready to answer questions on them. All right. Make sure you're ready to answer questions on them when we see. So this is where we're going to stop for the night. It's been a beautiful one. It's been a smooth one. And tomorrow 6 p.m., tomorrow 9 p.m., we'll be seeing each other. Thank you guys. Enjoy the night. Yeah, it's very possible. Somebody asked me about calculus. We could solve questions by 9 p.m. on calculus. Yes, of course. We are going to touch literally almost all topics. So you see, we did logarithm, we did functions, we did binary operation today, right? So we'll do more topics tomorrow, and we would keep doing. We still have Sunday also. We'll keep doing more topics. So it's revision time. It's time to answer lots and lots of questions. Okay, so don't worry. And by the way, we are coming with calculus class very soon also. Calculus class from scratch. We'll do lots of classes on calculus. So you guys take care of yourself. Have a good one. Have a good night.